Hello, PVS parents and scholars. I'm bringing to you the very first installment of my Steamposium distance learning activity. Since we were not able to have our Steamposium family night, I have decided to make some videos of some of the experiments that we would have been doing. And hopefully the ones that I'm presenting will be easy for you to do at home. They're made out of mostly materials, hopefully, that you have around the house. And I hope you enjoy this series. Okay, so very first one is a science experiment called Strawkets. And this comes from a series called Science in a Bag. So it's a science challenge, remembering that STEAM stands for science, technology, engineering, art, and mathematics. So the very first thing is, what is a rocket? Let's watch this video.
On December 18th, 1958, America launched a rocket that broadcasted a Christmas message from space. The message was recorded by Dwight D. Eisenhower, who was the President of the United States at the time. The mission was considered a great success, as it launched the first ever communication satellite into orbit and laid the foundation for what is now an essential multi-billion-dollar industry today. The communication satellite used to broadcast the Christmas message came to be known as the Talking Atlas, as it was launched aboard an Atlas rocket. A rocket is exactly what you think it is: a long, thin, metallic cylinder with a pointed nose that shoots up from the ground, leaving a gigantic cloud of smoke in its wake. However, there is more to it than that. There are a number of other things that make a rocket both functional and useful. The word rocket can mean different things in different contexts. Simply put, a rocket is a spacecraft, missile, aircraft, or other vehicle that obtains thrust from a rocket engine. From the outside, the frame of a rocket is very similar to that of an airplane. It's made of various light but very strong materials, like aluminum and titanium. The skin of the rocket is covered with a thermal protection system that protects the rocket from extreme heat caused by air friction and helps maintain cold temperatures that are needed for certain fuels and oxidizers within the rocket. The body of a rocket is composed of different sections, all of which are housed within the frame of the rocket. The first component is the payload system of the rocket. For the uninitiated, the payload is the rocket's carrying capacity. The payload depends on the type of mission the rocket is being used for. It can consist of cargo, a satellite, a space probe, and even a spacecraft carrying humans. So, if you want to send humans to space, the payload of your rocket will contain a spacecraft. Whereas if you're using the rocket as a weapon, then the payload would consist of a missile. Next is the guidance system, the system which ensures that the rocket stays on its intended trajectory and goes where it's supposed to go. The guidance system consists of onboard computers and sophisticated sensors, as well as radar and communication systems to maneuver the rocket while in flight. Last is the propulsion system. A majority of the entire length of a modern rocket is actually made up of the propulsion system. As the name suggests, the propulsion system consists of the components that help launch the rocket off the ground and subsequently propel the rocket in a given direction. So how is this huge, enormously heavy cylindrical metallic tube shot into space? In order to get into space, the rocket must first cross the thick layers of atmosphere that envelop our planet. Since the atmosphere is thickest near the ground, the rocket has to go extremely fast in order to get past this part of the atmosphere. So how does it climb so fast in the air? The answer to this question lies in one of the most popular physical laws of the universe, Newton's third law of motion. According to the third law, every action has an equal and opposite reaction. In our case, we have a rocket that we want to launch into space. How does the third law help us? This law tells us that if we can get the rocket to push against the ground with an enormous amount of force, then the ground will respond by pushing the rocket upwards with an equivalent amount of force. That's where the rocket engine comes into play. A rocket engine works by burning either a liquid or solid fuel in the presence of an oxidizer. When the combustion reaction occurs, it throws out a great deal of mass as a byproduct of the reaction. These byproducts are released at great speed through the bell-shaped nozzles that you see at the bottom of rockets. Since the rocket pushes the exhaust down, the exhaust responds by pushing the rocket up at great speeds, which lifts the rocket off the launching pad and propels it upwards into space. In a way, you could say that a rocket shoots upward by throwing hot gases from its exhaust nozzles below. If you have ever seen a rocket launch in person, or even seen a rocket launch video on the internet beyond the liftoff phase, you may have noticed that a rocket doesn't maintain a straight trajectory all the way up. It lifts off perfectly vertically, but at around the 1-minute mark of the flight, it starts turning and going laterally. That is a flight maneuver known as the gravity turn. It's a trajectory optimization technique that's always employed while launching rockets because it offers two benefits. First, it uses gravity to steer the rocket onto its desired trajectory, which helps to save rocket fuel. Second, it helps to minimize aerodynamic stress on the launch vehicle. If a rocket continued going up without tilting at all, it would reach a point where it would run out of fuel. That's why it tilts slightly after lifting off straight up, thanks to the exhaust nozzles of the rocket, which can be swiveled from side to side in order to alter the direction of the thrust. Once a rocket lifts off, parts of it are sequentially separated or jettisoned at predefined intervals. For instance, if a spacecraft is being launched with a rocket, then its rocket boosters are separated first, followed by the external tank. These separated parts blast off from the spacecraft and splash down into the Atlantic Ocean, where they can be retrieved. The spacecraft then maneuvers on its own using its main engines to reach the desired orbit. Similarly, if an unmanned satellite is launched on a rocket, the sole purpose of the rocket is to get the satellite into its intended orbit. Once there, the satellite stays in the orbit and does a small amount of maneuvering using its own engines. All in all, rockets are used only to get stuff into space, period. Once a rocket has done its job, it's separated, in parts, from the stuff that it carries, as it's no longer considered an operation requirement of the mission. Space agencies all over the world have been sending men and material into space for decades now. As such, it's only fair to say that we wouldn't have been able to understand and explore space nearly as much as we have, if not for those tall, cylindrical, metallic tubes that shoot up from the ground in a bid to expand man's reach beyond this planet.
Okay, so for your experiment today, you're going to have to gather up your materials. There's a list right here. You do not need the gallon Ziploc freezer bag, but a straw, marker, pencil, 2 cotton balls, 2 pieces of paper, and some Scotch tape or stickers. Here's a video of me showing you the materials.
Hi, Mrs. Antiso here, coming to you from my house. I'm just going to do a quick video here on one of our Steamposium activities that we're going to do at Steam Family Night so that you can try it at home, and hopefully you have some of these materials. The very first thing you need to gather is you need to get 2 sheets of computer paper. So there's 2 sheets of paper here. You're also going to need a pencil. You're going to need some kind of pen. I have an Expo marker handy. You could also use a Crayola marker or some other thicker marker. You're going to need a straw. You can use a regular plastic straw, or in this case, this is one of my daughter's cups for one of her cups, so a plastic straw will work too. You're going to need tape, and you're also going to need 2 cotton balls. So hopefully you have some of these items in your house. If you do, go ahead and gather those up for our experiment.
Okay, so for the next part, I'm going to discuss the activity directions. You're going to be making 2 different rockets. We call them Strawkets. One using a pencil and the other one using a marker. You take the pencil and you roll the piece of paper around the pencil. Then you tape it closed. And you use a cotton ball to plug up one of the ends. And then you insert a straw into the open end of your Strawket. And then you can launch it. I have a video of the directions on the next slide.
So for the first part of the experiment, you're going to take your pencil and 1 sheet of paper, and you're going to roll up your pencil inside very tightly your sheet of paper. So roll it up all the way across. Then you drop the pencil out of it and you take a piece of tape and you tape this roll closed. The For the second part of your experiment, you're going to take your second sheet of paper and you're going to roll it in your marker. This is going to make a larger roll. You still want to make it tight against the marker. Again, drop out the marker, add a piece of tape or two, keep it in place. Then you're going to take your 2 pieces of cotton and you're going to stuff it into the end of the hole. You might have to squeeze it a little bit to get it inside the hole, but you want to plug up the hole on the end of your paper roll. So I plugged up the end of the small one. I'm going to plug up the end of the larger one. And you can even put a piece of tape over the top if you want to. Make sure that it's sealed and that the cotton ball stays in there. Okay. And then the last step is you're going to take your straw, you're going to insert it into the end that doesn't have the cotton ball, and then you're going to blow into the end and launch it. You're going to do the same thing with your larger rocket. You're going to put your straw inside the end. You're going to blow into the end of your straw and launch it. Go ahead and try that.
Okay, so for the activity, before you launch it, look at both of your Strawkets and make a hypothesis about which one you think is going to go further. Do you think the larger tube will go further, or do you think the skinnier tube will go further? And why do you think this? Now, you can either write this down on a piece of paper, or you can just talk to someone in your house about what you think your hypothesis is going to be. Then you can do your experiment. You stand in a room with your feet in a certain spot, and you launch your Strawket that you made with a pencil first. And then you do the one with the marker, and you write down what the results are, or you can tell somebody in your house what the results were. And then what is the force that's pushing the Strawket forward? So talk to somebody at your house, or write down what force do you think it is that's pushing that rocket forward. So after you have tested it out, you probably know a little bit more about rockets, but there's some important vocabulary words you need to know: force, distance, gravity, and air resistance. So let's talk about why your rocket is launched once you blow air into the end of your straw. If you use the same amount of force to blow each of your Strawkets, the skinnier one should have gone farther. When you blow the air in the wider Strawket, some of the air comes back through the space inside the Strawket. So the straw is closer in size to the skinnier Strawket, which allows the force of the air to move mostly forward. Other forces also impact the distance of your Strawket and how it travels, like gravity and air resistance. Think about other ways that you can make your Strawket go even further and make changes to your design. So if you want to add something to your design, you can go ahead and add to your design now and test it out to see if it works better. So what did you learn from this science experiment today? Write about what you learned on a piece of paper. You could draw a picture, or you can tell someone in your house what you learned from this experiment. And finally, my last video.
I hope you had fun trying this experiment, and stay tuned for the next episode where we will be doing a technology experiment. Bye for now. Test out my rocket. Ooh, that went pretty far. Bigger rocket. See you later.